In this lesson, we shall find composition of two or more functions and then compare the domain and range. And let's start with different operations that we can do to get a new functions. We can do addition, and here you can see we have this function and this one. We can add them together. We could subtract them together and get a new function. We can also do power functions. So these are examples of power functions. And then moving on, here we can also do multiplication, multiply two functions. Like if I multiply these ones, this is what I get. I can also divide, this is what I get. And this takes us to the lesson. And our lesson for right now is composition of functions. And this is the notation you have seen before. We are making a new function, h of x, by combining these two functions. And the way the composition works, you have the first input, which is x. You put it in, and the machine produces g of x. You plug in g of x into f of x, and you come up with f of g of x. So note that function, and I want you also to remember this notation. So we have f of g of x, and see, this is the same as f, and you're going to see that symbol, and it's the same thing, and you're going to see that is the same notation, so same thing. And here we are given two functions, and we are going to find the domain. We are going to combine them or do composition and then find the domain and range. And let me start with f of g of x, and I take the f function, and the f function is, you can see it's the one with 2, and then instead of x, I'm going to use a different color here so that you can see. I'm going to plug in x squared minus 1, and this is power negative 1. If I simplify that, see, this is the same as 2 over x squared minus 1. And see, when I graph this function, see, this is the same function here when you graph it. And I'm just showing a graph there because that's another way to visualize the domain. Now, how do I find the domain? I know x squared minus 1 cannot be 0 because I cannot divide by 0. So that means x cannot be equal to plus or minus 1 when I solve that equation. So that means it can be any number except plus or minus 1. So I'm going to write the domain. So from negative infinity to negative infinity to negative 1, and then union, then it's going to start from negative 1 to negative 1 to negative 1 to 1. Then remember, it cannot be 1, so then it's going to start from there, 2. So from 1 to infinity. So that's going to be the domain of that function. And you can see that on the graph. You can be able to see that on the graph. There are two breaks. There are two breaks on the graph. Those are the two breaks. And you can see that is called the U. The U is showing the 3 parts of the domain. And let's look at the next one. We're going to look g of f of x. So I take the g function. So I take, instead of x squared, I'm going to plug in, instead of I'm going to plug in 2x -1, and see, that's I'm taking the g function and all this squared -1, and I could simplify this. Remember, this is the same as 1 over 2x, all that squared -1, and see, this is the same as 1 over 4x squared -1. If you graph this is what you get, and you can see the domain here. We take 4x squared cannot equal 0, so that simply means x cannot be 0. So it's going to be every number, all from -infinity to 0, then union from 0 to infinity. So that's going to be the domain of that function. And you can be able to see it from this graph. It can be any number except 0. Now let's look at how to find the range. The best way to find the range is just by looking at the graph. Like, see, this is the graph we have here. We are looking at now the y-axis, and you can see the domain is all the numbers, and you can see it here, all the numbers from -infinity to 2. When we are looking for the domain range, sorry, we always start from the bottom, so -infinity to -2, and -2 is included, and then it starts again from 0 to infinity. Best way to look at the range is to look at the graph and see the next one. Look, to find the range, you can see y is any value which is greater than -1, so from -1 to infinity. Okay, let's look at another one here. So I'm finding, I need to find f. I need to find f of g of x. So I'm going to take the f function. So x squared plus 2. Instead of x, I'm going to plug in 5x squared plus 2, and that's going to be 25x squared plus 2. Oh, actually, I don't need to. Let me go back. Let me back up on this one. I'm taking the x function. So instead of x squared, I'm going to plug in 5x minus 1 squared plus 2. And I'm not going to simplify it because that's not our focus here. When I graph it, you can see this is a quadratic function. That's how it's going to look like. And you can see the domain is simply all real numbers. So that's the domain. Now let's go to the next one. I take g of f of x. And how do I do that? I take the g function. Instead of x, I'm going to do x squared plus 2, and then minus 1. And you can see this is going to be the new graph, so this is not the correct graph here. And when I look at this graph, I can graph it, but I can see that the domain here is going to be all real numbers. It's a quadratic function, it's a parabola, so that's the domain. To the next one, and see, this is how the graph of the previous one looks like. Okay, so here to find the range, you can just graph it, and you can see for this function, the domain starting from down, you start from 2 going up, because it keeps going down, going up. So if y is greater or equal to 2, or that's the range. And for the range for this one, it starts at 9 going up. And here is an application problem on what we just did in physics, and you can follow this example. And then you can work it out. I'm going to go over that, so I'm going to stop right there.